here we go with example number 3. So you are going to use trig form. So the first complex number you have is 4 plus 3i. 4 plus 3i is not in trig form. So step 1 would be review from yesterday to put it into trig form. So if z1 is equal to 4 plus 3i, this is your x value, this is your yi value, or your a plus bi value. If your x is positive and your y is positive, that would be in quadrant 1. So I'm going to draw my triangle in quadrant 1. Remember, your right angle is on the x-axis, your angle theta is here at the origin. My x value is positive 4. And remember, again, that when we're graphing these, you would label your y-axis yi. The x-axis is still labeled x. So my x value is positive 4, my yi value is positive 3. I have to find the length of the hypotenuse, that's r. This is a Pythagorean triple, it's a 3, 4, 5 right triangle. So our hypotenuse is 5. Now I've got to use my tangent function to find that angle theta. Tangent of theta is equal to opposite over adjacent. The opposite side is 3, the adjacent side is 4. So my theta prime is going to be inverse tangent of 3/4. Now, 3/4 is not a tangent value that we know from the unit circle. The values from the unit circle that we know for pi over 6 are radical 3 over 3. At pi over 4, the tangent value is 1, and at pi over 3, the tangent value is radical 3. But this value we don't know. So you would have to use your calculator. I did this question, so when you're looking at my notes, please copy all the notes down, follow my notes. I use degree mode on my calculator, so pop your calculator into degree mode, do second tangent 3/4, and I'm just going to give you the rounded value. Theta prime turns out to be 36.870 degrees. 36.870 degrees. And because the triangle is quadrant 1, we don't have to move that into another quadrant. We're going to use our theta prime. So for this 4 plus 3i, for this complex number, the trig form of that complex number, z, remember, is equal to r times the cosine of theta plus I times the sine of theta. That is review from yesterday's notes. The trig form of this complex number, r is the hypotenuse, it's 5 times the cosine of 36.870 degrees plus I times the sine of 36.870 degrees. So we're going to call that our Z1. Now, the second complex number that they give us is 1 plus 2i. Now you have to do the exact same thing with this. You have to, step 1, put it into complex form. So if Z2, oh, this pen is not working well. Let me try another one. Z2 is 1 plus 2i. And we have to do the exact same thing again. We have to first put it into trig form. This is your x plus yi value, or your a plus bi. So x and y are both positive. This triangle would be in quadrant 1 again, where our x value is positive 1, our yi value is a positive 2. You have to find the hypotenuse, use the Pythagorean theorem. 1 squared is 1, 2 squared is 4. When you add those together, you get 5. So the r, the hypotenuse of this, would be the square root of 5. Probably some of you are going to have to actually write out the Pythagorean theorem to do that, but please do that. Now you have to find your angle theta using the tangent function. Again, the reason we use tangent is because you always go back to your givens. Tangent is opposite over adjacent. The opposite side is 2, the adjacent side is 1. So we're looking for an angle whose tangent value is 2. It's not a value I know from the unit circle for tangent. I'm going to go to my calculator again. Theta prime is equal to inverse tangent of 2. I'm again working in degree mode. And when I did this on the calculator, I got a rounded value of 63.435 degrees. 63.435 degrees. So for Z2, the trig form of that complex number, here's the formula for the trig form of a complex number. It's R, which is the square root of 5, times the cosine of 63.435 degrees, plus, this should all be on one line, plus I times the sine of 63.435 degrees. So now I've taken my two complex numbers, again, review from yesterday, I put them into trig form, and now to do the product and the quotient, Z1 times Z2, you would multiply the coefficients. The coefficients are 5 and the square root of 5. And you would add the angles. So it would be the cosine of 36.870 plus 63.435, and then plus I times the sine. When you add those together, you get 100.305 degrees. Now you'd have to go to your calculator, you'd have to do the cosine of 100.305, distribute your 5 radical 5. To do the quotient, Z1 divided by Z2, remember you divide the coefficients, so it's going to be 5 divided by the square root of 5. You don't have to rationalize that denominator because you're going to use your calculator to distribute it. You would subtract the angles, so it would be the cosine of, if you're subtracting the angles, it's going to be 36.870 minus 63.435 degrees plus I times the sine. When you do that subtraction, you get a negative 26.565 degrees. Then you have to go to your calculator, you have to do the cosine of the negative 26.565 degrees, and then distribute your 5 radical 5. I really think you're going to be able to follow this. I hope that everybody's doing okay. Today is a beautiful spring day, and I hope that you can get out for a walk. I don't want you to do any more work over the weekend except for this homework assignment that's due on Monday. I'm going to have hopefully more information for you on Monday about where we're going with this course and what's happening. Remember though, I do have to finish the material for this because it is a college course. You guys have more requirements for this course than some of your other courses where you're just doing some review work, but I'm confident that you can do it. Please continue to email me and message me, and I hope you're all well. I miss you and looking forward to seeing you again soon.